Okay guys, so this is section 8, topic 7, and it's about end behavior of graphs of polynomial functions. So remember, end behavior is talking about as the graph approaches positive infinity or as the graph approaches negative infinity. So we're going to look at each direction. So as x approaches positive infinity for this graph, okay, as x approaches positive infinity from left to right, then y approaches positive infinity as well. So as x increases, then y increases as well. Okay, as x is going up from left to right, so as x is going up, y is also going up. As x approaches negative infinity, as x goes down, okay, then y also approaches positive infinity. Okay, it increases. So you could say that either way. So for this particular graph, for y equals x squared, as x increases, y increases, and as x decreases, y also increases. Okay, so let's continue. So y equals negative x. Now remember, y equals negative x is just the reflection of this graph over the y-axis. So for y equals negative x, as x approaches positive infinity, y approaches negative infinity. Okay, as x is going up, y is going down. So as x increases, y decreases. And then as x decreases, or x approaches negative infinity, then y also approaches negative infinity, or decreases. Excuse my writing there. Trying to squeeze it in. So for these, in both cases, it's increasing, and for this one, in both cases, it's decreasing. Let's look at two more. So these two, y equals x to the third, that's a cubic. So these, remember, are called quadratic. Okay, those are both quadratic graphs. These are both cubics. Okay, cubed to the third power. So for these two, we're going to have a little bit different scenario over here. So over here, as x increases, as x approaches negative infinity, y increases. Oh, sorry, said y and wrote y. As x approaches infinity, y approaches infinity. Okay, so as x increases, y increases. And I get that from saying as x is going up from left to right, y is also going up. Okay, and then as x decreases, as x approaches negative infinity, y decreases. Y approaches negative infinity, or so as x decreases, y decreases. Okay, so as x increases, y increases, as x increases, y increases, and as x decreases, y decreases. All right, let's look at the bottom. So for this one, it's just backwards. Okay, similar to a quadratic, the negative in front of the x cubed does the same transformation. It reflects it across the x-axis. So over here, as x approaches infinity, as x goes up from left to right, so that would be this direction, y goes down. So y approaches negative infinity. So as x increases, y decreases. Okay? And then as x decreases, as x approaches negative infinity, y approaches positive infinity. So as x decreases, y increases. Okay, as x goes down, y goes up. And you can see that from these graphs. Moving right along. Let's continue. All right, so we have a table here, and we're going to fill in on this table what happens. So f of x is equal to x squared. So the sketch of that graph was this. Okay, and f of x equals negative x squared. Here's the sketch of that graph. So it says use the observations to sketch the graphs and make conjectures to complete the table. So as x approached infinity, f of x also approached infinity. Okay, we wrote y on the other side, but same thing. As x approaches negative infinity, f of x also approaches infinity. So we're just kind of summarizing it all in a table from here. For this one, as x approached infinity, f of x approached negative infinity. And as x approached negative infinity, f of x approached negative infinity. So we're conjecturing here. And then for, this degree of the polynomial is even, means this second power right here. Okay, so that would be like second power, fourth power, sixth power, and so on. Okay, so if the degree of the polynomial is second power, fourth power, sixth power, these properties are going to be true. Okay, if it has an even degree, then the leading coefficient is positive. It's going to be approaching infinity on both sides. If the leading coefficient is negative, it's going to be approaching negative infinity on both sides. So it's going to be pointing the same direction. Okay? If the degree of the polynomial is odd, that would be like linear. So first degree, third degree, so a cubic, fifth degree, and so on. Okay? The cubic f of x equals x to the third. Okay, if we look back at that one, that's not as familiar to us as these two are. So let's look back. So this was my y equals x to the third, starts down and goes up in a curve like that. So that would be like this. And then my f of x equals x to the negative third while we're here is opposite. Okay, it started up and went down. So like this. Okay. So as x approached infinity for it, f of x approached positive infinity. But as x approached negative infinity, f of x approached negative infinity. And then vice versa here. As x approached positive infinity, f of x approached negative infinity. And as x approached negative infinity, f of x approached positive infinity. So now that we have this, we can use this for any function. We could use it all the way up to 5th degree, 7th degree. We could use it for a 27th degree polynomial, without having to see the graph, we could know the end behavior as long as we knew whether the leading coefficient was positive or negative. Now remember that leading coefficient being positive or negative for a quadratic or an even polynomial is pretty easy to see because of the way it opens up. If it opens upward, it's a positive leading coefficient. If it's opened downward, it's a negative leading coefficient. Now my odd polynomials are a little different, but we will discuss those as we go. So let's practice. Consider the following graph of f of x equals, or of f of x, it's this graph. Does the function have an even or odd degree? So let's talk about that. So remember, I determine my even or odd degree by, one way I can determine whether it's an even or odd degree is by whether the end behavior is consistent through both. Now my end behavior here is both approaching negative infinity. If I take it back to this table, the only time that both are approaching negative infinity is if the leading coefficient is negative and the degree of the polynomial is even. So does the function f of x have an even or odd degree? It has an even degree because the graph opens in the same direction on both sides. So even because the graph opens in the same direction on both sides. Okay, generally, one way to think about that is that generally our even numbers are more neat, they're more tidy, and these have the same, they open on the same thing. It's a little neater looking than the ones that go in different directions. So then it says, is the leading coefficient of f of x positive or negative? So it is negative because both approach negative infinity. So as x approaches infinity, then f of x approaches negative infinity, and as x approaches negative infinity, f of x still approaches negative infinity. You also could say that it opens, it's not exactly perfect, but it opens downward. Okay, it kind of opens, it points down the same way a quadratic would if it had a negative leading coefficient. So now let's talk about the end behavior of this function. So this one we don't have a graph for. You could type it in your calculator. You could look at it like that. But I also want to analyze it just by purely looking at this table and looking at what we have. So we have to the third power. So the third power, that's an odd degree. And we have -5 as my leading coefficient. So we have an odd degree and a negative leading coefficient. So if I have an odd degree and a negative leading coefficient, if I go back to my table, then that tells me negative leading coefficient, odd degree, okay, that's going to be as x approaches infinity, y, or f of x, approaches negative infinity, and as x approaches negative infinity, f of x approaches infinity. Okay, so we need to be able to reason through those. So it might take some studying over these especially. These I think we can get. These we might have to study over for a little bit to know that if the leading coefficient is positive, okay, it goes from down to up. It's kind of like slope. One way to kind of memorize this is that it's like a positive slope. It goes up from left to right. Whereas the negative odd degree goes down from left to right. It's decreasing. Okay, so it's kind of an easy way to remember the general shape of the graph. Consider the following graph of f of x. So we look at this graph. Does the function f of x have an even or odd degree? Now, I notice they're pointing in opposite directions. Okay, they're pointing in opposite directions, so it must have an odd degree. Because the graph opens in opposite directions. Okay. Is the leading coefficient of f of x positive or negative? Now we could look at that end behavior, but we also could do what we just said of it kind of has a positive slope. It's increasing, okay, generally from left to right. It's increasing, so it has a positive slope. So as x approaches infinity, f of x approaches infinity. And as x approaches negative infinity, f of x approaches negative infinity. Okay? So if it has a positive slope, it's kind of going up from left to right. As x increases, y increases. Okay? So let's take a look at this crazy looking function down here. Remember, we said that no matter how crazy the function looks, we really just have to pay attention to two things: the degree and the leading coefficient. So the degree here is 6. So it's an even degree. Keep that in mind. And a positive leading coefficient. So if that's true, if we take it back over to my table, now a few things we can kind of memorize to make this easier instead of having to go back to that table every time is an even degree means they're either both positive or both negative. Okay, so let's go ahead and set this up. So as x approaches infinity, and then as x approaches negative infinity, I'm looking at each one of these. I'm going to set these up and then we can chat about making sense, trying to not rely on the table as much because we do have to kind of reason through these. So it's even degree, so we know that they're going the same direction. This is either infinity, infinity, or negative infinity, negative infinity. If it's a positive leading coefficient, then we know that it's facing upward. So if it opens up, okay, and it's an even degree, then they would both have to go to positive infinity. You could even come over here and check it on your table if you wanted. It had a leading positive coefficient. Okay, leading coefficient is positive, and degree of polynomial is even. So it is approaching positive infinity on both accounts. Okay, so then determine which of the following statements is true for the function f of x equals 3x to the 5th plus 7x minus 4247. Okay, for this one, we have an odd degree, which means it's going to be pointing two separate directions. And then we have a positive leading coefficient. So that means that my graph is increasing. Doesn't mean that it opens up, it just means that it's increasing and it's coming from two different directions. So this is probably not what this graph looks like. I have no idea, but I know that the general trend is that it's going up from left to right and it ends in two separate directions. So as x approaches infinity, f of x approaches infinity, and as x approaches negative infinity, f of x does not approach positive infinity, it approaches negative infinity. So let's find the answer choice that has that. So I'm looking for x approaches infinity, f of x approaches positive infinity. That one doesn't work. As x approaches infinity, f of x approaches positive infinity. So as x approaches infinity, as x goes up from left to right, y also goes up. And as x approaches negative infinity, as x decreases, y also decreases. Okay, so that would be D. You could also bring it back to the table. Odd degree. The leading coefficient was positive. So that was infinity, infinity, and negative infinity, negative infinity, which is what we just picked in this answer choice. If you have any questions, let me know.